Hello, my name is Ikenna Omekam, and this is my final lab. And I decided to do something similar to the first lab where we were measuring the change in velocity of an item. My interests were robots, and I was just curious to see how long. Well, I was curious to see if robots really move at a constant speed. According to specifications in the motors both spin at negative 127, and according to that, the speed is supposed to be the same. And so I'm just testing that. So I'm going to show you. I just had a short video clip. I'll just pull it up really quickly. Okay, I didn't. It's literally just the robot moving. So I'm trying to see if this is the same speed. Technically, the motors are both being supplied the same amount of energy, and it's pushing the robot with the same amount of force. So technically, it should be constant throughout. So let's play through that. And yeah, that's my video. And I constructed a little visualization for that. And it's not much. It's just this. I wasn't really interested in the whole plot. I was really interested in the data that came out of it. And I'm going to show you the graph I got out of it. Let's get it over here. Where is it? Oh, I actually Google. I don't have Excel anymore, so I should just put it here. Perfect, right here. So this is the data and the graph I got from the tracker over here, and then I also combine it with the data I got from my Python. And as you can see, the data is relatively simple. It's relatively the same. See if I can find my graph over here. While that's loading, I could talk about like the principles I use. I use the basic kinetic principle. The main thing trying to be found was like how to update the velocity, which is I just used the whole momentum principle. Delta P is equal to net force times time, and from that to derive my velocity and my change in. Here's the graph, and you can see it's relatively the same. Now it doesn't look like the robot stayed in constant motion the whole time, but then again, that could also be included with like the friction of the carpet it was on. It could be included on the battery and supplying less power over time and stuff like that. And so this is pretty much just helping me prove that even though the robot is programmed to move at a constant speed, it's not actually a constant speed. Like I said, I use the basic kinematic equations. Yeah. Let's see, if I'm forgetting anything else. That's pretty much it. Here's my data from my tracker. Here's my data from my Python. I'll show you some of the code in my Python file. I have the net force updating over here, my velocity updating. I assumed everything was in the x-axis because the robot, as you can see over here, is very, very small changes in the y direction. It's even reflecting the data over here. Very small changes in the y direction. And so I just decided to just make this solely in x because it's really only moving solely in the x direction. Okay, so, and then I have my position update, which is just taking the whole position, equal to the old position plus the velocity times time. And so I got that. It's pretty basic stuff in my opinion. It's just more of a rehash of the first lab, but I found this problem to be interesting because I'm a TA for the 101, and I often get students ask me why is my robot going the same speed each time, even though it's supposed to, what factors account to it. And that is all I have for this lab assignment. Alright.